In a previous video, we learned how to factorise quadratics when they are in the form of ax squared plus bx plus c. We did this by finding two numbers which added to give us the b value and multiplied to give us the c value. In all of these previous examples, however, there was no coefficient of x squared, so there was no a value. You can see for these two that there is an a value, which makes it a little bit harder to factorise. However, in a case like this, and the first thing you should always check if there is a coefficient is there a common factor that I can take out? So for our first example, you notice that all of them can be divided by 2. So in this case, I have a common factor, or a highest common factor actually, of 2. So if I was to take the 2 out the front and then factorise the rest, I'm left with x squared plus 7x plus 10. So now that I have my x squared by itself, I can solve as I did previously. So I need to come up with two numbers that multiply to give me 10 and add to give me 7. So looking at that, I know that what I'm going to use in this case is 2 and 5 because that fits it. So now I'm left with, we don't forget about this 2, we still keep that one out the front. So I'm left with 2 times x plus 2, next brackets, x plus 5. And there is your final answer for this one. The next one, just as easy, except there's one slight trick that a lot of people always forget about. So you look at it and automatically you know there is a common factor of 5. However, if we're looking at the highest common factor, you notice that they're all negative. So our highest common factor is actually negative 5. So by taking that out the front, I'm left with positive x squared plus 4x plus 3. So once again, I need two numbers which multiply to give me 3 and add to give me 4. In this case, that's a pretty straightforward one. We know that 3 multiplied by 1 is 3, and 3 and 1 are the only factors of that, and 3 plus 1 equals 4. So in this case, I'm left with negative 5 outside of x plus 3, next brackets, x plus 1. So you can see that by taking out a common factor, we can factorise just like what we've been doing.